This is Mr. William Bago from Unibek Group of School. This is our revision class for JSS3 Basic Science. Today we'll be revising the topic work. Work is a common phenomenon, it's a common term mainly used by us. We use it in our day-to-day activity. Now, when we are talking about work, scientifically, we are referring to the distance moved by a body that a force is applied on, or we can say is the distance that the body moves when a force is applied on it. Now, so we can also refer to it as, you can say, work is force times distance. Force times distance. Now, this work has a unit. The unit for work is measured in joules. That's the unit for work. Now, each of these have their units. Force is measured in Newton. That's the unit for force. Distance is measured in meters per second. See, quite important for us to know that. Now today, we will go straight to the point. Remember I said work is force times distance. Work, force times distance. Now work can also have another formula, especially when you are dealing with work in a vertical motion. Now, work can also be mass times gravity times height. This is another formula for work. MGH. Another formula for work. Mass times gravity times height. Now, please let's take note of this formula. Very important while we start solving. Now, let's start with the first question. An example. Example 1. A force of 150 Newton is applied at an angle of 60 degrees to the horizontal to pull a box through a distance of 50 meters. Calculate the work done. Now this is quite a simple question. But first of all, before we start solving, now we have a question here. A force of 150 Newton is applied at an angle of 60 degrees to the horizontal to pull a box through a distance of 50 meters. Calculate the work done. Calculate the work done. Now, in solving such a question, you interpret the question. Now, this is the angle in which the box was moved. But take note, you have a force of 150 Newton. You have distance in which it moved of 50 meters. Now, in our question here, we are having force, having distance. So what it means, we're going to be applying the formula force times distance. So now, force is 150 Newton Now, no need for us using this 60. It's just there. It's just showing us the angle in which the box moved. But you don't need it in this question to solve. The distance here, 50 meters. Now, so we are looking for the work done. Work done. It's unknown. Can you see? And applying our formula, we know that in solving this, we know that work done equal to force times distance. And what's our force here? 150 times what's the distance? Hope you understand what I'm doing. It's quite simple. The distance is 50. So when you multiply 150 times 50, you're going to be having 7,500. So you say your work done, 750. Please don't forget the units. 750 what? Joules. You can put it, spell it fully, or you put it as J, the abbreviation. Now, example 2. Example 2. Now let's solve this. Example 2. An orange of mass 5 kg, or let's use 2 kg, falls freely from a tree to the ground through a distance of 2 meters. Calculate the work done, taking G as 10 meters per second square. Now you see constant. It's a constant. So now in solving this question, solution. Now look at it. Here we have mass, we have distance, that's the height. We have G. So in this question, we will be applying the formula, the second formula for work done, which is mass times gravity times height. So the mass here, so remember from the question you know the formula to use. This is very important. Mass is what? 2 kg, that's the unit for mass. The distance. Now distance here is a vertical distance. So meaning it's falling from the top. It's a vertical distance, meaning the height. Please note that. Vertical means that it's falling from the top. That's where the other is falling from. So yeah, you can call it height. So vertical distance, 2 meters. G, that's the gravity. It's a constant, the additional constant is 10 meters per second square. Work done. We don't know work done. So in doing that, we're going to say work done equal to what? M times G times H. That's mass times gravity times height. That's mgh. See? Call it. So, in putting it, work done is equal to what's the mass? What's the mass of the orange? 2 kg, 2 kilogram. Times gravity is a constant. As you can see, it's constant. Then, and what's the height in which orange fell from the tree? The height is 2 meters. So say work done 2 times 10, 20. 2 times 20, 40. So the work done is 40 joules. You can put J only, leave it like that anyhow. You can put J only or you spell it in full, please. 40 joules, that's the work done. Finally, let's give a final example on this. On this example 3. Hope you are understanding what we're doing so far. Example 3. A force of 16 Newton moves a load through a distance of 20 meters. Calculate the work done. Calculate the work done. I will see this question here. Now, solution. Now, first of all, before you start solving, you bring out what I call the parameters. The what you're looking for. You know, so you're able to know what you're looking for. Each of the values. Now, force here is 16 Newton. As you can see, moves a load through a distance of 20 meters. Now the distance here is what? Distance is 20 meters. Calculate the work done. So the work done here is not known. So what do we do from our formula? You know that work done. Now please, from the parameters, you will know the formula to use. We're having force and distance. It means we are using force times distance. Force times distance. Using force times distance here. You can see. So work done. What's the force? 16. What's the distance? Move 20. 16 times 20. We're having 320 joules. So the work done is 320 joules from the question. So I believe we've all understood what we've learned so far. Let me give an assignment so that you'll be able to test your ability. Assignment regarding this. So you just test to know if you've really gotten what we've done so far. Assignments. A body of mass 30 kg falls from the top of a building at a distance of 12 meters per second. Calculate the work done. So please try and do these assignments and test your ability. I still remain Mr. William Mbago from Unibek Group of School. I believe you've gotten what we've learned so far. Hope to see you in our next class. Thank you very much.